Welcome to class 10. Today we are going to start the first chapter of chemistry, that is chemical reactions and equations. You must have noticed when freshly cut apples are exposed to air, they turn brownish. Similarly, what happens when milk is exposed to room temperature during summer or an iron nail is left in humid air? In each case, there is a change in nature and identity of the substance. This change in nature and identity of the substance is called chemical change, and this happens due to chemical reactions. So, the chemical reactions are the interaction between two or more substances resulting in chemical changes in them. How do you know that a chemical reaction has taken place? Now, go through these observations. If there is evolution of a gas, release of heat and light, or change in color of the reactants, or change in physical state, then these observations can help us to understand that chemical reaction has taken place. Now, change in physical state does not mean that ice will melt to form water. There are reactions like candle burns to form carbon dioxide and water vapor. Their candle, which is wax, which is in solid state, will be converted to gaseous state. So in some cases, change in physical state also will be a chemical change. Now, to understand these chemical changes properly, we have to go through some activities. This activity 1.1. Here, magnesium ribbon burns in air to form magnesium oxide along with light and heat. Now, what are the observations for this? Magnesium metal gets converted into white powder of magnesium oxide due to reaction between magnesium and oxygen. So, this is the first observation. There may be other observation also, that is dazzling white light is formed. You can see the magnesium ribbon, which is a soft strip of magnesium which burns with dazzling white light. Now, if this magnesium oxide is collected and a few drops of water is added to it, it will be forming magnesium hydroxide. Now, this will turn red litmus blue. What does this indicate? It indicates magnesium oxide is basic. That is why it dissolves in water to form magnesium hydroxide, which turns red litmus blue. Now, next activity, that is lead nitrate solution is mixed with potassium iodide solution. Both are colorless solutions, but when they are mixed, they will form lead iodide, which is yellow solid or insoluble salt, along with potassium nitrate, which is soluble solution, it is aqueous. So when a colorless solution of lead nitrate, say this is lead nitrate, which is colorless initially, and potassium iodide, which is also colorless, when they are mixed, instantaneously there will be yellow precipitate formed, that is of lead iodide. Along with that, there will be potassium nitrate. So what do you mean by precipitate? Precipitate is the insoluble compound which is formed and thrown out of the solution. So what will be the observation for this? First observation is two colorless solutions, when are mixed, they will produce one yellow solid, that is lead iodide salt. Second observation, on standing, this lead iodide or these yellow particles will settle down, leaving a colorless solution above it. This colorless solution will be of potassium nitrate. So that means you can also write that in this product, one is insoluble and yellow in color. So we are able to see. Another is must be white salt and soluble. That is why it will be forming colorless liquid, colorless solution, right? Next activity is 1.3, that is when dilute acid is taken in a test tube and then zinc granule is dropped in it. What happens? there will be zinc chloride, which is a soluble salt, will be forming a solution, and there will be hydrogen gas formed. Now what is the observation here? See the figure properly. You can see the bubbles are sticking to the surface of zinc. These bubbles will be coming up from the surface of zinc, showing there is a gas which is colorless and odorless. And if a burning matchstick is brought close to the gas, there will be pop sound. That will indicate that the gas is hydrogen. So in this, what are the observations you will write? You will write bubbles of a colorless, odorless gas. This is the first thing. Second thing, if we touch the test tube, it will be warm. So it shows that there is heat also produced. If you are asked to write the third observation, you can write that after the HCl is already used up, then zinc will stop reacting, and then the surface of zinc will be looking black. Okay, this is the third observation. So you can write all the observations of these activities in your notebook. Next is what are chemical equations? Chemical equations are the symbolic representation of chemical reactions in the form of formula and symbols. The substances that undergo changes are called reactants, and the new substances formed are called product. Now, if the chemical equation is not balanced, that is called unbalanced equation or skeleton equation. We always need to balance a chemical equation, as mass cannot be created or destroyed in a chemical reaction. Now, to balance an equation, what you have to see, that number of atoms of each element remains the same before and after the reaction. So first point what you will see during balancing of equation is formula of any reactant and product cannot be changed. That is why they are written inside the box. We cannot change the formula. Second is start balancing the compounds having maximum number of atoms. So in this type of reaction, this is the one which is having maximum number of atoms. So we will start balancing with this. Now just we should go one by one to check how balancing can be done. So here magnesium reacts with oxygen to form magnesium oxide. First you have to write how many atoms of different elements are there in the skeleton equation. So magnesium is 1, oxygen 1. Here oxygen in reactant part, oxygen is 2 and magnesium is 1. Now we want to increase the oxygen is 2 and 2 here. Now this is 1 here and this is 2, so we have to increase it. So we will multiply 2 here. In that way both will be increased. Then as magnesium becomes 2 now, we will increase the magnesium writing 2 here. So then it will be 2. So this is 2 magnesium plus O2, that will be giving 2 MgO. Similarly in this case we will start with this. In this there are 4 oxygen and 3 iron. So here oxygen in reactant part, oxygen is 1. To make it 4 we multiply 4. In that way hydrogen is increased to 8 and oxygen is increased to 4. So oxygen is balanced. Then 3 iron is alone here, we can write 3, so this iron is also balanced. Now hydrogen, this is 8 here, we have to write here 4, so that hydrogen is also balanced. Similarly in this reaction, AlCl3, in the product part, this is AlCl3, we start with this, there are 3 chlorine and 1 aluminium, there are 2 chlorine, okay, and aluminium is alone, so we can increase it in any way. So here if we want to make the number of chlorine atoms equal, we can multiply 2 with 3 and this 3 with 2. In that way chlorine will be 6 on both the sides. So if chlorine is 6, then aluminium is alone here. So if aluminium becomes 2, so we'll make it 2. Then copper has become 3, so you'll make it 3. This reaction is left for you to balance. So just check the number of atoms first in the reactant parts and in the product part, and try to balance them using the rules. Okay, so next topic is how to make a chemical equation more informative. Symbols of physical states of reactants and products are mentioned with their formula. So these notations like G for gaseous state, L for liquid state, S for solid state, and AQ for aqueous solution. These are the notations to be used along with their formula. Second part is the reaction conditions like temperature, pressure, catalyst are also indicated above or below the arrow. So take this reaction. Here carbon monoxide, which is a gas, reacts with hydrogen, which is also a gas, and it will combine to form methanol if the atmospheric pressure is 340. Under 340 atmospheric pressure, they will react to form methanol, which is in liquid state. If this reaction condition is not maintained, then reaction will not be taking place. Similarly, nitrogen gas and hydrogen gas, if they are collected in a cylinder, they will not react. But if the temperature is maintained at 500 degrees Celsius, atmospheric pressure is 200 atmosphere, and there is a catalyst, iron, which is used, then only nitrogen reacts with hydrogen to form ammonia gas. So the next is photosynthesis. Here atmospheric carbon dioxide will react with moisture and will produce glucose along with oxygen if sunlight and chlorophyll are present. So reaction conditions are too important for chemical reaction to take place. Now those conditions can be expressed in this way to make the chemical equation more informative. Next topic is types of chemical reaction. Chemical reactions involve breaking and making of bonds between atoms to produce new substances. That is why there are different types. Now first type is combination reaction. In this, two or more substances combine to form a single product. Just like A, this is one substance, will react with B, which is another substance, will form a compound AB. So what is most important? This is only, the product is a single compound. There may be two or more reactants, but product only will be one. That is called combination reaction. Here also it is given A and B, they are the two different substances and they will form a compound AB. Now examples, carbon or a piece of coal burns in air to form carbon dioxide. So here two different elements or substances react to form a compound. Here hydrogen and oxygen at very high temperature will react to form water. So here also there are two elements which will combine to form a compound water. There are other examples given in your book. Those are, say, calcium oxide. What is the name of calcium oxide? Common name, quicklime. You remember, most of you are not able to write what is the formula of quicklime in the last final exam of class 9. Now see, this is quicklime. When water is added to quicklime, that is calcium oxide, it forms calcium hydroxide, that is slaked lime. Along with that, lot of heat is produced. So this is again combination reaction where two compounds combine to form the third compound, but this is single. Product is always a single compound. Now ammonia reacts with HCl, hydrogen chloride gas, to form ammonium chloride. So this is the salt, already you know, you have read it during sublimation. This is the ammonium chloride is an example. So this is formed when ammonia gas reacts with hydrogen chloride gas. So these are the combination reaction. Now, exothermic reactions are the reactions in which heat is released along with the formation of products, like methane, which is the most important and main component of CNG, that is burnt or reacts with oxygen to form carbon dioxide and water along with heat. So when heat is produced along with other products, this is called exothermic reaction. Similarly, the process of respiration in which carbohydrate is broken down to form glucose and glucose combined with oxygen to provide energy, this is also exothermic reaction where energy is evolved. But these are not combination reaction. These are only exothermic. There may be examples which is combination as well as exothermic, like this. Calcium oxide plus water, that gives calcium hydroxide and heat. So this is combination as well as exothermic. But these are only exothermic reaction. Okay. Then go to the next type, that is decomposition reaction. It is just reverse of combination. Here one single compound will break into two or more products. So that is called decomposition, a reaction in which a single reactant breaks down to give two or more simpler products due to heating is called thermal decomposition reaction. So this is the activity 1.5 on thermal decomposition reaction. Here ferrous sulfate heptahydrate, which is light green in color, when heated gently it will form ferrous sulfate which is white in color because of loss of water of crystallization. Now if this white anhydrous ferrous sulfate is heated strongly, it will be forming three products. One is the brown oxide, that is ferric oxide, along with other two gases like SO2 and SO3. Now see this diagram. So with the help of burner, ferrous sulfate heptahydrate, when heated, then it will be losing water of crystallization, and this water of crystallization will be collected as droplets of colorless liquids here on the inner part of the test tube. Why this is cooler part? This is the cooler part of the test tube. Why? Because this is tilted and this part is heated, right? So this is the cooler part of the test tube. There will be condensation and you can see water droplets here. Then if it is heated more, then obviously this will evaporate. Then ferrous sulfate will decompose to give three products. Two gases will be coming out, SO2 and SO3, and ferric oxide will be left in the, that is brown color, which will be left in the test tube. So what are your observations? First observation is water droplets collected on the cooler part of test tube on gentle heating and turning of green color salt to white, right? Next, when on strong heating ferrous sulfate will decompose, then we get the gases. So there will be smell of burning sulfur due to sulfur dioxide. So these are the observations you have to write. Just see the observation in the next page. These are the observations, that is light green color of crystal is lost and white salt is formed. This is due to loss of water of crystallization. Droplets of colorless liquid are collected on the inner surface of the test tube, which is the cooler part, and will facilitate condensation. On further strong heating, smell of burning sulfur is obtained due to sulfur dioxide. Then there is another activity on the same, that is thermal decomposition. So here lead nitrate is heated strongly to produce lead oxide, nitrogen dioxide and oxygen. These colors are used to help you to observe. Now during heating, first observation is crackling sound is produced. So when this is heated, there will be crackling sound. Second, reddish brown gas, that is NO2, formed. So next observation is this, that is reddish brown gas is formed, which is nitrogen dioxide. Third observation is yellow mass, that is lead oxide, is left in the test tube. These are the gases which will be coming out. What is left in the test tube is lead oxide, which is yellowish in color. Okay, next topic is electrolytic decomposition. So when a single substance decomposes to form two or more substances, when electric current passes through the compound in molten state or in aqueous solution, it is called electrolytic decomposition. Now if we take acidified water, why acidified? Because pure water is bad conductor. So a few drops of acid is mixed with water to make it better conductor. So when electric current passes through acidified water, it will break into hydrogen and oxygen. Now see the diagram. So this is activity 1.7. Here there are two electrodes which are inserted in the beaker and they are connected to anode and cathode of the battery. Anode is connected to this, that is positive terminal is connected to the anode, and cathode means this graphite rod is connected to negative terminal of the battery. So that makes it cathode, right? Then water is poured in the beaker so that these electrodes are totally immersed. After that, there are two test tubes which are taken and they are filled with water, and then these test tubes are placed inverted over the electrodes. So you can see this is the test tube which was initially filled with water, but it is placed inverted over it. This one is also the same, it is placed inverted over this. Now when current will pass through it, there will be splitting of or breaking of water to form hydrogen and oxygen. Now what do you observe? Study the diagram properly. First thing you observe that there are bubbles. So first observation is bubbles are produced in both the test tubes. Okay, at both the electrodes bubbles are formed. Bubbles are coming out from the electrodes, right? This is the first. What does it indicate? It indicates that there must be gases formed in both. Okay, so first observation, bubbles are formed, indicating gases are produced at both the electrodes. Now second observation is there is lowering of a drop of level of water, right? Because if gases are formed, the gases must be not soluble in water, so that is why they will not be dissolved in it, and to create space for them they will displace water in downward direction, creating space for them, right? This is the second observation, that is there is drop in level of water. Now third is at cathode the space occupied by gas is double compared to the space occupied by gas at anode. Okay, so these are the three observations. Why it is so? If you see the balanced chemical equation, that is 2 volume of that hydrogen is formed and 1 volume of oxygen is formed when water breaks into hydrogen and oxygen. So these are the observations for electrolysis of water. Next, that is photo decomposition, we'll do next day.